This stream is live. We are fully functioning. And folks, apparently there's a lot of hubbub in the physics community. We're just finishing a stream. I'm joined with Jen here again. Let's just jump right into it.
Though I know I should be wary, still I venture someplace scary. Ghostly haunting, I turn loose. Beetlejuice! Beetlejuice! Beetlejuice!
All right, we're back. We don't need to go through the whole thing. Blatant advertising aside and everything. Welcome back to the Memes of Destruction YouTube channel, Jen.
Hi, Memes. Really good to be here. Thanks for having me back.
Yeah,
You saved me from this other terrible stream I was watching but couldn't manage to turn off due to my mild addiction to internet blood sports.
Yeah, that goes into another thing that I've kind of been pondering around. Just as a quick footnote, so this is on record, so I remember. I think the thing is with the internet, it's not necessarily always that somebody's like for this side or that side. I think a lot of folks just kind of love to see the chaos. They like to stir the pot, if you would. And as long as there's chaos and everything, and it kind of is, well, Rule 14 of the internet, everyone loves a good dumpster fire. It's like, who really cares who wins? But aside from that, space-time communication, that's what we're here to talk about. The universe. How does it even work? And this is one of the things that came up here. And again, this was a measurement, and Mr. Smolin had brought this up. Excuse me, Dr. Smolin. Lee Smolin on Professor Keating's podcast earlier. He did also have an Eric Weinstein there as well there. They had a bit of a chit-chat. And I learned something new that I had not heard before. Apparently, when they were doing the LIGO measurements of two colliding black holes or whatever celestial masses there were, apparently they took, according to Lee Smolin, a pretty clean measurement of basically the measurement of gravity or the gravitational waves, as they're referring to them too. And it apparently seems to be close to this measured speed of light as far as we know it. Essentially what's known as the cosmological constant. I'm saying that, I'm like, see?
Hold on, I don't think that's what people mean when they say the speed of light is the cosmological constant. That I think this wasn't
the theoretical maximum.
Wasn't the cosmological constant something invoked in order to solve some issue or reconcile some issue?
I think so. As far as I understand it, the cosmological constant is the hypothetical maximum speed of the universe, which, as far as I understand it, that we've observed, the fastest thing in the universe that meets that is the speed of light. But we can't actually directly measure the speed of light. I thought we had
measured some galaxies that were receding away from us faster than the speed of light.
But
that doesn't actually violate the concept that the speed of light is the speed of information transfer, though.
Right. Well, I believe isn't that redshift? It's like, all right, we're moving apart here, but this is moving
because
this way.
Each time a sun is created, some velocity is created along with it, right? Like this is going back to your E8 thing. It's like, what's velocity? What's momentum? It's like those things are derivative quantities of the measurement limit. And the question is, how many of these derivative quantities can we make of the measurement limit? The periodic table tells us, well, we have 3 plus 1, which then unfolds into 2 twice, because you have 2 elements in the first period and then 7 periods, but 4 cardinalities of period, right? So you have like an unfolding, but the unfolding still happens on the macro scale, right? Like the best evidence I could give for the dualism is actually the symmetry of our own bodies, like the fact of having 2 eyes and stuff. I'm not saying we're 100% symmetric, but there's clearly a high degree of symmetry in the human and animal bodies, right?
So time is essentially the keystone.
The keystone is understanding that the measurement limit is the thing underlying everything else is just manifesting differently, right? So when we talk about the measurement limit on the scale of the periodic table, that's the smallest scale. And then you go to our scale, you still have measurement limit. It's just less entangled. Space-time is less entangled on our scale. So what you have is the dualism manifesting differently. It doesn't manifest over 118 microstates. It manifests over 3 plus 1, but each of those 3 is subject to the uncertainty principle. So there are 2, right? There's position, momentum. So there's 2 there's one polarity or 2 ends of each spatial measurement. And so that is like a dualism, as best as I could put it, as to that's like sort
Monad.
of the what. It's not a monad. This is not.
I don't know. I thought that was the title, the subject.
If I was going to
used. I
invoke,
don't know.
if I was going to, the monad would be if I was going to try to tell you the shape
Is there
of
a
these waves.
religious
Connotation.
connotation? Yes, I was going to say context and connotation, but my mind was a little wobbly.
There's a religious connotation to everything because all human knowledge ultimately has its origins in religion, and what we, looking back, call religion. But back then, if everybody was the same, believing the same essential God structure, can you really say it's a religion, or does defining a religion imply the existence of multiple belief structures? Right. So you're into a question of semantics at that point. But
all I know is the way
we could say for sure. What we could say for sure is that religion is more fundamental to society than other ideological constructs. So you wouldn't want to say like, does it have a religious connotation? You'd want to say, what religious connotations does it have? And then you could contrast those with latter-day secular developments, right? Pseudo-objectivism that attempted to diminish the bias of the theological ideology that had hitherto been ubiquitous.
All I know is, if depending on which dimensionality we're looking at, I don't know. I think the speed of light goes up or down. At least according to some
we're talking about the number of microstates. C has to do with information transfer. Right now, we're just talking about structure. We're just talking about structure because structure tells us what the information is, and C tells us how fast the information can be transmitted. But we have to know what the information is before we can understand its transmission mechanism. We've got to spend more time on that.
How do we hack the universe?
Well, you got to understand what's happening entropically, right? Like, what is Boltzmann's equation?
I don't know. I'll bring it up.
So this is one of those things you should just sort of know off the top of your head, because there's a couple things in science that are so important that it's worth memorizing. For example, S equals K ln omega. We should memorize the fact that the entropy is determined by microstates. Not microstates per se, but the natural logarithm of the number of microstates. So what power do I need to raise e to to get my number of microstates?
How do we know?
It's not actually there. Just scroll down a bit. We'll see if we can find the actual equation.
Move that. N equals, is that the dimension?
This is the derivation of it, but you're just looking for you can put in second law of thermodynamics, because this is like the full derivation. It's way too long. I would just go to second law of thermodynamics. It's usually called Boltzmann's equation, but I think what you've got there is Boltzmann's law.
Oh.
Sure. See, it's like actually integrating
Boltzmann's entropy formula
of.
There you go. It's got entropy, so this must be what you're looking for.
We want to understand it.
Wait.
We want to understand it on a philosophical level.
This is SK sub B. Is that the
it's called the Boltzmann. It's called the Boltzmann constant, but we don't want to think of it in terms of equals KB, because our minds have a very hard time visualizing these constants, right? Like KB, even something like C, because it's not like we can sort of intuit something like velocity. That's pretty easy. It's like I can relate to velocity being a thing, but I can't really relate to KB being a thing. So the way to understand a formula like this is that the entropy is proportional to the natural logarithm of the number of microstates. Okay. So instead of saying equals a constant times, you think of replacing that with the entropy is proportional to the natural logarithm of the number of microstates. And then that way it's no longer an equivalent statement, it's a proportionality statement, which still follows the basic rules, but it's less unintuitive.
Is that joules over Kelvin, or are they saying just kidding?
That's joules over Kelvin.
Okay.
So what's the first thing we need to know about if we're going to intuit this stuff?
What
does the Lawn graph look like, right?
Okay.
So what does the Lawn graph look like?
What? Oh, something like this? I don't know. Something just came up. Is that it?
I can display it. Let's see. Y equals 1x. It's a pretty standard formula. I'll just share my screen real quick if that's okay.
Right. We can do that.
All right. So it will put up this guy. So
Right.
basically you have negative values until you get to 1.
Oh, so you hit 100% statistically or equivalent
Well,
measures.
no, because entropy wouldn't be able to be negative.
Got it?
Because if you have 1, right, it's not possible to have negative entropy, right?
No comment, just continue.
Well, entropy is derived from mass, so you couldn't have mass and have
I don't
negative
know.
entropy.
I thought matter was mass, and apparently antimatter might be a thing.
Well, matter is mass and non-mass. Matter is the set of everything that is understandable through the objective, quote-unquote, scientific lens. It's the catch-all.
I thought something always pushed off of something.
Well, no, of course not. Not everything is a duality. Some stuff's dual, some stuff is singular. Just really depends what you're talking about. But back to this idea that I was trying to get to about microstates, right? So we're trying to get to E8 using the basic entropy idea, which is that how many microstates do we have, right? So the dimensions are threefold over 1 temporal dimension. So you've got 3 space, 1 time. But each spatial is dual within the uncertainty principle, i.e. there's like position and momentum connection between position and momentum. So that's where you get the 2 to the power of 3. Because there's 2 poles in the uncertainty relation. And there's 3 dimensions. And the dimensions add on top of each other. So they're multiplicative in the terms of how many microstates they generate. So it doesn't, like, that's the fallacy, is we think it generates 3 microstates because we perceive 3 dimensions, but it's like, no, it's 3 plus 1 microstates that it generates. And where it crystallizes depends on the order of magnitude that you're on. So you get E8. So the question is, how do we go from E8 to the quantum periodic table? Because if we can go from E8 to the quantum periodic table, then we can figure out, because I don't exactly know what E8, how it's used. I can just tell you, you can easily get 8 from 3 plus, from the measurement limit, as long as you understand that each dimension is actually dual.
All I know is E8 is very pretty. Just because it has all those connection points, and then it just goes back and forth, and then it ends up forming this very spherical thing that if you continued up your E group or your exceptional Lie groups, I'm pretty sure that I don't know. Sounds pretty. Isn't that how Newton or somebody was trying to calculate like the curve of a circle?
I'm not sure. It's the first I've heard of it.
Okay, no, that's something else. But continue.
Yeah, it's a cool diagram, but yeah, we basically have to account for the entanglement on some level. Right. Like I can't look at this and tell you that it's right or wrong. It doesn't look necessarily one or the other. I can't tell how it goes from math to that particular geometry, though.
No, that's fascinating, because when I think E8, I just think of Gary Leese because he's been exploring that. And then Dr. Weinstein said, well, he was exploring E8 just because you're looking at how things are supposed to line up, and it also happens to be very pretty. So I just find it fascinating that you're just like, oh, look, I look at math of E8 and I'm like, ooh, pretty. Just different conceptualization.
Well, yeah, it's what you can use to explain like why we have eyes, right? Because we have 3 physical dimensions and then a dualism within our body. So the dualism is absorbed into our body and manifested through the symmetry of the body. Whereas generally, the dualism is just manifested on the level of there being 2 sides to the pole of the uncertainty principle times, or to the power of 3 dimensions, because you have to do it to the power because they're in different dimensions. So E8 is basically your basic number of spatial microstates.
Okay, hold on. I'm looking at 2 to the 14. 14, that sounds like dimensions or something like that to me. There's a whole bunch of other things, and then we get up to that. Looks very. I mean, isn't that technically what we measure as the speed of light per second in like meters or feet?
Well, meters per second is 3 to the 8.
Okay.
So that's 6 to the 8, or 7 to the 8. Okay.
248 dimensions.
So it's 7/8 of the speed of light.
That's
like, you can't get lost in this uncertain and in this numerology stuff. Like,
is that just going to keep on going up and up? And I'm sorry to cut you off, Jen, but if the exceptional Lie groups just keep on going up and up, and we get closer and closer, I don't know at what point does it hit the speed of light. I mean, does we solve for something then?
It never hits the speed of light. The speed of light
is a constant curve. That's interesting.
No. That's not how it works at all. Like, the speed of light is just the speed limit. It's like a ceiling that you bump up against. And how far you are from the ceiling depends on how much etheric permeation there is in the substance. So if the substance is 100% etherically permeated, then you get C. And then once it's not, you get less than C. Just a matter of how dense it is. It's not actual density, though. It's etheric density, right, which is existing in the 14-dimensional universe. It's like, for example, our heartbeat is a slowing down of the speed of light. So think about how much impedance you have to slow it down that much.
It's not
a lot, right?
Yeah.
How much? I mean, a fuck ton. How fast is the heartbeat? It's pretty slow. It's like a centimeter per second.
Whoa.
So what's the ratio between 3 to the 8 meters per second to 0.01 meters per second?
This is a completely voluntary class, Dave. Shout out to my patrons, Dave and Joe Franco. This broadcast is helped made possible by viewers like you.
Yeah, thanks for joining, guys, and be sure to tell your friends about the stream and bring their questions if there's anything in particular they're interested in, because I think we're into some pretty high-level stuff.
I just keep on going back to the hyperbolic figure 8 knot that Thad Roberts was analyzing. I'm like, okay, again, maybe it's just coincidence. Maybe it's a theory of everything.
It's the basic causal. It's your basic causal loop. It's an untemporalized causal loop, right? Because 3 plus 1. So e to the 8 comes from the 3, right? Because it's 2 to the 3. So the 1 hasn't been integrated at all. Okay, so it's a detemporalized entity. It's your basic quantum, but you've removed the time.
We've got the 8 there. We've got your 8. I don't understand it, but I see the 8s around here. Continue.
Well, that's all we've got is just that. Like, there's not a lot of information in the universe. There's tons of data, but there's not a lot of linear. Like, the question is, how much is linearly independent? So if I had to break down the universe into a basis, how big is that basis?
The Planck constant, or I don't know. That's what he analyzed it as, and just things that can't. This is what makes me think there might be something to it, just because. Okay, even if you happen to hit, because this was supposed to be the big thing with E8. E8, look at how many things line up here, but we're still not quite to ground. It's like, oh, okay, that's cool. But it's a reference point. It's like, okay, we're seeing how this works. If this does not work, what may actually work in this particular instance? All right, let's take a look. If you have this hyperbolic figure 8 knot, it's like, all right, if you need to slow down space-time, what would be the smallest closed?
You can't slow down space-time. You can't slow down space-time. Space-time exists on a more primal level than velocity. You can't define an intrinsic velocity to space-time because velocity is derivative of space-time. It's
perhaps I meant energy, or maybe I actually do mean space-time. I don't know. I still think black holes kind of might gobble them up.
Well, we both know you have this obsession with bending the laws of physics for some strange reason.
Well, but in order to go beyond the possible, we need to delve into the impossible. I thought that was the name of Professor Keating's podcast.
That's just an insipid one-liner that may or may not be true. if you want results, you go by the method that's worked in the past. That's what science is all about. The question is deciding whose authority is actually valid in science.
That's cool. That's why you have crazy people like me trying to like break the rules of the universe. Why? Because we can, or at least try.
Well, people have tried that forever and never had any success. So to continue trying that is unscientific.
Insane. Well, it's insane.
Well, it's unscientific, and it is possibly insane to call something unscientific scientific, yes.
Well, you don't try to do it the same way.
People calling me crazy because they are upset about what I said because it's too true for them to handle isn't the same as literally driving someone crazy because you keep derailing the subject to it's just a rabbit hole that goes nowhere.
Well, it means nobody would ever get butthurt on the internet.
Well, you're in a dark cave that's infinitely large, and it has one exit. It's a maze, not even a cave. It's like a maze. It has infinity false exits and one real exit.
Okay.
So how do you get to the exit?
Flow.
You don't know how to blow.
No, I said
every
flow.
microstate.
I said flow. Well, you need to do that by entropy. You would need to take the route of absolute least resistance. I mean, that would maximize your chances to actually get to where you needed to go.
And how would you know the path of least resistance?
I ain't good. I don't know.
So yeah, it's all like what I'm trying to do is set up a metaphor for authority.
Oh.
Right now, your authority is contrarianism.
That's true.
That's where does that go? That just goes nowhere.
No. I push, and then I'm like, okay, I see logic, and then I try to account for Goebbels' theorem. It's like, all right, well, the more we try to know, it's like the more factors we're going to have. This is going to get difficult. So it's like, That's why I talk to people like you. Okay, so Boltzmann's constant. What do we need to understand?
Someone's asking if gravity has anything to do with time. So mass has gravity. So anytime you have mass, it has a gravity field. So I wouldn't say mass creates gravity, but you can think of it that way. If you want to look at it as a really, broken down step by step, mass instantaneously creates gravity. And then you have gravity acting on the mass. Whenever there is mass, there's gravity acting on it. And then when the mass acts on itself, you can start to get space-temporal observations. That's where time comes in. So mass is more fundamental than time.
Now, if mass is a form of a topological construction, and depending on what it is, like a heartbeat, in order to slow down, would essentially be whatever the theoretical max was the speed of light, the cosmological constant, basically energy. It's like that's pretty dense. And then if you're even going by the more basic building blocks, it's like, all right, you got your atom here. How much of it's a nucleus? Like, a bit. Are there some quarks in there? Maybe.
Well, that's the thing. Like, you wouldn't want to believe in something unless you had evidence for it. So you have to decide what's your standard of evidence.
You've got me thinking about that. I'm sitting there. I'm like, what? How do I know quarks exist? It's like, well, they told me. I'm sitting there, and I'm seeing this. I took a look at some of those pictures, and somebody actually conceptualized something similar. Like, I saw some of these pictures. See, we can fire. It's like, and he's kind of trying to map out. It's like, you see the one here and the ones there. And I'm sitting there. I'm like, I mean, you can make that assumption. You can generate that hypothesis, but I'm like, I mean, could it just be a malformed kind of oscillating sphere? I don't know. I'm listening to what you said. I'm like, they haven't proven it. And I'm sitting there. I'm like, the singularity. I'm like, I was just using singularity and black hole kind of interchangeably. I'm sitting there. I'm like, there's a difference. There is a difference here.
Well, singularities are not part of science. If you accept singularities, you're outside of the domain of science, axiomatically. The person in the chat's asking about black holes being space without time. No, E8 is space without time.
I can go either way. I can go what's math.
E8 is derived entirely from 3, which is space. So E8 would be space without time. What a black hole would be is mass, which is undifferentiated, right? So what differentiates mass? Space-time observations. What are they? Things bounded by the measurement limit.
Right.
And what's that? Well, that depends what order you're on. Okay, so it would be mass without space or time. That's why you call it undifferentiated. This means that space is not differentiated from time. Once matter is excluded from the black hole, that's where the differentiation takes place. And it all has to do with what's the maximum entropy state, because you have to consider the attributes of the dark matter. I don't like to call it a black hole. I prefer dark matter. You think of the attributes of extremely exhausted matter, right? Because we're looking for the maximum, the universal max entropy state, i.e. the energetic bottom of the universe. So what happens is that all energetic differentials are erased, and as you go to the max entropy state, but you can't erase the quality of mass. Excuse me, because we have conservation of mass. So mass eventually gets to its maximum entropy state, and the question is, what are the attributes of this state? Well, potential for chemical action would be gone by definition. The potential for giving off any kind of light through internal processes would be gone. So that's why it's dark. And then, it just has gravity. So basically, it's very dense because gravity is an attractive force. So what's the maximum entropy state when you're in hyperdense? That's going to be the proton electron set turning into a neutron. Versus if it's just a free neutron, it's going to turn into the proton electron set. Not because of any internal difference to its mass, its own matter, but because it's in a less dense medium, i.e. it has to do with how much ether has permeated your system. So when the ether is highly permeated, the max entropy state is proton plus electron. And when the ether is not highly permeated, i.e. dark matter, max entropy state is neutron, because what it's trying to do is minimize the action of the gravity field. And it does that by minimizing the net effect of the gravity field, which is to assume the lowest possible volume given its matter constituency, right? Because the neutron is, if you look this up in nuclear physics, you'll see there's an equation for transition in both of those directions. So I'm not saying anything that hasn't already been validated by science is my point.
Okay, because when you say that, this just comes to mind. I'm just imagining those holes from like Acme. You just throw it on the ground and you just go into it, and this seems to be the inverse of what you were kind of showing.
I'm not sure I get it. Sorry.
It's Wile E. Coyote from the old Warner Brothers
just don't
cartoon.
understand. I don't understand the metaphor. Sorry.
No. It was a bad. I was looking for the actual throw on the ground things, and then this came up, so I saw the line that looked similar to the inverse of what you were showing before. So I was trying to be funny. My apologies.
But yeah, it's not about time stopping near a black hole. That doesn't make any sense, right? Like time is something that is defined relative to the creation of a star, because the way we measure time is by how much decay there's been in known nuclearly reactive atomic species, right? So time
You're
would be
talking like
said,
nuclear
okay,
physics.
yeah, this big time event went by because of the emission spectra corresponding to these proportions of radioactive elements, which we can infer through knowing their half-life how much time has gone by through how much proportion of them is left relative to some pre-calibrated standard. God knows what that is, but it is all calibrated to the same standard. So that's why we get basically all the planets in our solar system the same age. So that number may itself not be accurate, but the information, since it's all using the same basic center, is giving us approximately the same age for all of them, because there was a single moment of creation in the total solar system, after which time became differentiated, where before it wasn't differentiated, right?
Is that locally or?
Well, localization, what is that? What is localization? What does that
What's
word
going
mean?
on around us?
It is the process of something which was diffuse becoming concentrated. Localization means going into a location. A location is a specific physical region. So if you say something is localized, you're implying that it used to be diffuse and then became concentrated.
Oh, we got a Duvid. We got a Duvid in the house. Oh, we're
I
talking
know.
the science. Welcome, good sir. Welcome. Good to see you. But okay, so we already broke the cosmological constant earlier. You're like, well, what about the redshift galaxies? And that was I brought it up in a lot of the inferenced way to Professor Keating before. And he's like, well, we were counting the best we can and everything. All right, be honest. I'm like, but I'm sitting. I'm like, wait, hold on. Now we can infer that. I'm like, well, it appears like it's going faster when we account for this redshift. I'm like, wait a second.
Nothing can
mean-
be accelerated to the speed of light. That's still true, but the outer rims of the galaxy were not accelerated to pass the speed of light. They were excluded. So things can be excluded past the speed of light because what's the limit? Because you got to think of it like it's a process that happens stepwise. It keeps happening. It doesn't just happen once. Like a star gets created, then a star, then another star, then another star. So each of these stars, when it's instantiated, has a velocity because the velocity gets localized. Because now space-time is differentiated. Those are the same thing, and they're connected through the measurement limit.
Because it's following entropy. It's achieving a stable-ish process.
It has no
parameters.
it has no impedance force. It has no impedance force. It is
Well,
localized
except
to a
the
particular
other
momentum.
stuff. Oh, you're talking on the solar level. The solar system.
Imagine the sun. When the sun gets created, it's localized to a position momentum.
This reminds me of that hyperbolic figure 8 lecture before, because I'm thinking about this because his conceptualization is like 5 parameter scales, and like the way they kind of just loop over. It's like you're at a certain level. I think you start off at like the Planck level, and you start going up to like a nuclear. Hold on, I'll go find the diagram. Okay, maybe it might take me a moment to find it because I'm like, all right, hold on. I need to go back to the video. It'll take a moment, but continue.
Okay, so the way to understand it is that there's very little impedance in space. Why? Because space is mostly comprised of ether. It's mostly fully etherically permeated, if you prefer.
I love how we're going back to that term. They used it so long ago. It's like, no, you're wrong. And then it's like, even Professor Wolfram's like, yeah, they were kind of right. They're kind of right. It really seems that way. It's a much easier way to conceptualize what is space-time. Well, that's the thing.
Yeah, we have to always remember that we can't overestimate our own intelligence and expect good results from that. And we should intentionally bring things to the most intuitive level possible, at least for the instantiation of axioms, right? So we, like I say, 3 + 1, that's intuitive. Then when you go to apply it, it's like, holy fuck, it's really confusing. But at least the first step is intuitive, that like no one's going to disagree that we're in a 3-dimensional universe spatially with 1 time dimension, right? Yeah. So that's why I've worded it as 3 + 1, because it's like anytime you want to do a sanity check on your axioms, it's like, yeah, I am in a 3 + 1 universe. Maybe I misunderstood what that meant in a particular application, but I'm reasonably certain that I can be confident in that axiom, right?
Well, I mean, it's as far as our observations and everything go, and that's why, depending on how you want to break it up and everything. All right, here we go. This is his conceptualization right here. Basically, you have multiple circles that just end up going about and connecting in all these different ways. It looks like he's measuring the different vectors and everything here. This is essentially via the hyperbolic figure 8 knot. I think what he said is you have 5 essentially like folding points or something along those lines.
Well, what's a fold, right? Is a fold a measurement? Because we got to figure out how it relates back to measurement. Because if they haven't oriented their system to be measurement centric, they're going to have problems with the implementation of the observer reducer.
Whatever the heck you're trying to do. Right. And again, it's just the main part that, as far as I understand it here, is he analyzed the hyperbolic figure 8 knot, which is essentially the smallest closed loop balanced manifold, to my knowledge. So I'll stop that, bring it up over here. So hyperbolic figure 8 knot, but the measurements, and again, I haven't verified these, but he's just like, just type into Mathematica. I'm sitting there, I'm just
you can't measure these things. You have to decide which one of these things is the best framework for making measurements, period. Because we're pre-measurement, right? Like you can't test to see if this stuff exists because we're arguing for a metaphysics. We're arguing for axiom.
My
Can't observe axiom.
my thing is, and again, if the only reason like it just really is impactful to me, and again, perhaps this is just my synchronization bias here, is the sheer fact like I'm listening to this while I'm out for a run, and just about 12 hours later, we're getting like results from like the muon -2, and again, maybe it's off again. It's only like 4.2 sigma, and again, it's from the same measurement equipment that Professor Keating brought up to the lab that was done at the experiment for like 20 years ago. So it's like, okay, you're using the same equipment. I realize it's very expensive, but when we just pop over here and it's like, all right, we look at this and it's like, all right, yeah, I don't know. That to me is very pretty. That's very pretty. It also pre-confirms my biases about a similar object I've just had in my head for years, but I didn't do the little twisty thing and run it through.
Well, can you see the 3+1 in there?
Well, I see. It looks like there's 3 sides, and then you're twisting it around, and it's running through itself.
Well, how many compartments does it have?
Is that 1? That's 2. That's 3, and then it's flowing.
Well, it only has 1 compartment, right?
Oh, the inside.
It's like, I mean, what does it mean when something is folding? Like, I'm having trouble translating this geometry. This is my problem. Is like I don't even think these people know what the fuck they're talking about. Like, I honestly don't think these people know what the fuck they're talking about. I'm sorry.
I have no idea. All I know
is what I'm saying, and it's like this makes no sense to me, and you don't have axioms, and it's frustrating.
That's true, but just if the numbers line up, everything seems to line up within.
You do realize you can jam numbers in to make stuff seem plausible, even if it's wrong, right?
I mean,
this is what I mean when I say numerology is the first step towards insanity, because you're basically trying to find numbers to shoehorn your data into a predetermined cosmology.
Have you watched the video?
Which one?
Oh, this one here, source code 7.
So all 4 of those represent the condition of split square.
The equations are pretty, and I'm not a math person.
So our argument is going to be pick one of those. It doesn't matter which one. I'm just going to go with the first. Okay, and as a little quick aside, if you're more comfortable with talking about splits and divisions and rotations, all in terms of E, hyperbolic sign is defined that way. I'm going to stick with this form because I think it might be less confusing to more people, but we shall see. I mean, in the end, the notation needs to be something everybody absorbs. We're just talking about the cousin of cosines and sines, right? This is the hyperbolic versions of cosines and sines, which of course being balanced with the circles. So hyperbolas and circled unit balances is what we're talking here. All right, continue.
I'm just saying this might actually be worth doing like a full stream on, just because I'd like to. I've listened to it, and I hear things, and a lot of things you're saying, I'm like, this looks very familiar. This sounds very familiar. I'm pretty sure the Boltzmann constant has been used in here too. I don't know. Let's see. Transcript. What is it? Okay. Maybe it's not. Maybe it's not. I don't know. Maybe it didn't transcribe. I don't know. It's just all I know is I look at these things and I'm like, all right, if this is true, maybe, but I know is I just want to talk about. I don't know.
Me neither. So if you can't explain it and I can't understand it, what are the chances anybody else will?
Oh, well, I mean, this was also just going for like 30 seconds of a video completely out of context. So,
well, that's why I'm saying, like, what does this predict? Nothing.
A bone. It provides, at least at some point here, predictions for what was it? Basically the 17 elementary particles and stuff. Where is it? It's over here. So yeah, this is where he has like the Planck charge. Like basically, these are the ones that we have as current predictions or measurements. And then this is his, and essentially it keeps going. So This is what he says. This is what he says. This is why I'm curious. If you happen to have some availability, maybe this weekend or something, at some point, I'd love to go through and actually like pop over to Mathematica and actually plug some of this stuff in and see if it's true.
Well, I mean, I'd be more interested in seeing if there's some way to put the system in axiomatic terms. Because right now, like, I can't just jump into this because, like, what are the axioms? Like,
it's right here. It goes through the Platonic. So the core axiom is essentially, basically you do, vectors, sides, and faces, and there ends up being a very common theme in that ends up being always something, and then he basically just kept applying that, and that's how he ended up getting to. It basically starts off with the Platonic solids and stuff. But
so, if geometry is fundamentally responsible for the constructs of physical reality, then humanity has a path towards implicitly obtaining the logic of existence.
That'd be cool.
I don't even think I agree with that, because if you know the structure, it doesn't necessarily mean you know the function. This is essentially the Platonic error. I would say this is what led Platonism off the rails and into irrelevancy.
Ooh, Bone is here for the axiom. No, this is interesting. I actually would like this is a completely different thing that I just brought up, and I would actually like to demote it, because like this is like a 2-hour video, and actually go through and actually play for some of this. I'd be down for at least at some point over this weekend. If not, maybe the following week, just to go through and just kind of play with this to get the axioms and lay it out, just because it's like, okay, again, all I know is I've met so many smart people, whether it's Jen, whether it's on Discord, whether it's just come across freaking that on Twitter and stuff. I'm sitting there, I'm like, there are smart people out there. And I'm like, oh, in my opinion, I'd love to see them have a few more folks that maybe check them out there. I'm like 705 folks that happen to be around him on the YouTubes. I'm like, I don't know, what happens if 1 million people looked at this? Would other people take a look? And even if he's wrong, did he open up another path or happen to touch upon something that maybe some other folks had worked on and just put it in a little bit of a different context, a little bit of a different framework that maybe other folks will look at and be like, oh my God, this is completely what I needed. And maybe we could actually level up. I don't know. I think it would be kind of cool. Just my opinion. But it is getting
wrong. You're not wrong. I mean, that's how you level up. It's just that you can't level up without initiation past a very low level.
Yeah.
There's a ceiling. There's a ceiling for what you can auto level up, but it's not unworthy of exploration. It's just unrealistic to think you can figure it all out on your own.
Oh no! Well, that's the point. It's to put it out there so other people can view it at some point. This is the only reason I've come here, just because I'm popping around. I'm going through these. This news was just draining my soul. I'm like, all right, I'm gonna stop watching as many Tim Pool videos. I'm just gonna start to get into physics and science things again, because I swore it off years ago. Because I'm like, all of a sudden back in high school, it's like, oh, you're taking like nuclear chemistry or something. We happen to have an uplink with what ended up being my alma mater. They end up having like a little nuclear reactors, like a Cobalt 66 or something, for some experiments there. And at one point we have the uplink, and I asked the professor, I'm like, so professor, if we could split like the atom, I'm like, what happens if we were to split like the neutron or something? Basically, all I know is what I end up pitching to him. He's like, he paused for a moment, took a breath. He's like, well, in theory, you would have created what's known as a neutron bomb, something with a lower explosive yield, but unleashes a massive amount of electromagnetism and kills every living creature in the area. At that point, I realized, as a half Jewish individual, I'm like, I should never go into physics.
Wait, what? I don't see how one leads to the others.
I assumed I would create weapons of mass destruction. I felt like that was where I would be pointed, so I'm like, all right, I'm not going to go into this.
So you're a bioweapon, basically.
I mean, you could totally say that, but life has a funny way of working out, and now I'm completely in it. Oh, you want to sign up for the Wolfram summer school?
What does it entail?
It's video lectures. I think it's for the week of, I want to say like June 1st through June 6th. There's a bunch of workshops and stuff like that, and basically they'll assign you projects and stuff like that, and basically you just you work on it. I don't know if it costs money. I still haven't signed up. I think it's free.
I don't think I'm willing to do homework. Like, I'd be willing to
No,
go
I-
on the
I
show
think-
and tell them the right answer and just be like, stop looking at it this way. Look at it this way and you'll get the right answer. But I don't know if they actually want me to do that.
No, I think you would actually be appreciated because that's the thing. It's like a lot of folks there are very pleasant and sometimes just bring up a different perspective. It's like this is one of the reasons why Dr. Wolfram does it. He's like, I have live chats, and again, is he out there saying salacious things? No. So very often you have a very controlled work group. So to look at the chat, and be like, that's a good idea. Let's take a look at it. It's like you're harnessing the power of the internet and like other people. It's like, why the hell wouldn't you do that? I mean, it just seems like a great idea. I mean, that's the thing. It's like, why the hell would I be out there solo grinding by myself? It's like, you got a lot of other people out there that know a heck of a lot more than I do. And so it's you just kind of link people up and kind of get folks working on different things. I think it would be fun.
I did everything. I did everything alone. Everything.
Okay. Well, I mean, you've hit a high level. We'll take a level 80 scientist. I'll totally do that.
I'm just saying, like, I feel like I can't really learn anything from other people. I know that's a horrible thing to say and everything, but I can't really change how I feel.
Well, could people learn from you?
Well, yeah, definitely. It's just that people get into this mindset where everyone has to be able to teach someone something, and it's like, you're not going to teach me anything.
Well, I mean, you could work on something cool.
I want to. I just feel that's the barrier, is people get offended at the fact that I don't want to learn from them. I do want to teach them, but I don't want to learn from them. People seem to think there's got to be some sort of like kumbaya thing where everyone's teaching and everyone's learning, whereas I just feel like that's a huge waste of time.
I mean, isn't that a little bit narcissistic? Or
Okay, Duvid teaches me things in subjects that I really honestly don't know anything about, and I'm grateful for that.
There we go.
So there's Duvid. Okay, so but that's one person.
Right.
And there's a range of subjects. I'm not interested in Duvid's hot takes on my science theories any more than anyone else's, though. But Duvid has other realms of knowledge that I'm, interested in and blessed to have the company of. So obviously,
I totally hear you. No, I totally hear you.
I do the weekly with Duvid because I like, in my eyes, he's a star. He's interesting. He's cool to listen to. But like, do I want to go into the average random person's hot takes on fill in the blank here? It's like, probably not, unless they've demonstrated a reason why I should give a shit. Most of the people I find, they don't have opinions I find interesting. There are things about them I find interesting, but I'm not like, I don't want to. I don't know how to say it. I want to placate people, but I don't want to be like giving people the wrong impression about what my goals are here. I figured it all out on my own. I don't want to change it, and I won't change it unless someone prove goddamn to a high standard that I'm wrong.
All I know is, with all due respect to it, I love you. I realize I am a horrible Jewish dragon kid on this internet stuff and thinks I really don't care about Dubit's chance or anything like that. It's just like, I mean, that is not a topic of interest for me at all. However, I found myself completely earlier utilizing the Duvid method of explaining a situation, just going through a metaphor. I'm just like, oh my God, it is so useful just because it's like, it's melodic and everything. And understanding that I'm doing it, I'm like, I feel so cheesy, but it's so effective at communicating a point.
Okay, here's the real question, though. Have you said "God forbid" yet?
Yes.
You've interjected because it's
oh
like
my God, I didn't even pick it up.
Like,
no, I almost
you
never.
can't get the timing right unless you interject.
Duvid, you've broken me. You're doing a good job. I still need to research to do it, but I'm gonna actually wrap it up here because I literally need to go run before it gets too late. But Jen, thank you all for.
In 3 days, we'll have Week in Review, so we hope you'll join us on that. Thanks for hosting and for continuing the conversation. I had a great time and look forward to the next one.
Absolutely. Thank you all for watching. Peace out, everybody. Be safe, and long live the elbow bumping. Don't forget your squirrel.
낮에는 따사로운 인간적인 여자 커피 한 잔에